Hi, this is Maggie. In this video we're going to animate a sprite. Animating a sprite can make it look more realistic. You can find some creative ways to avoid animating a sprite. For example, a car from the top doesn't really change as it moves, and a robot that hovers also doesn't need to be animated. But a creature, living or robotic, with wings or legs, or a car from the side with tires really needs to be animated to look realistic. And that's more fun and helps engage a player with your world. And animating a sprite isn't really that hard. Now, I'm not going to animate a moving sprite in this video. I'm going to animate a sign, which might appear in the background of a game, but the principles are the same. A sign doesn't have any of the additional complications of moving, so we can focus on just the animation. Now first, in order to animate a sprite, you'll need to have images of the sprite in its different phases of motion. When you have one image, which is a single sprite in different states, such as different phases of different kinds of motion, it's called a sprite sheet. You can use an image editor to separate the images into separate images you will load into your program, or you can use the original sprite sheet and just split one piece of the sprite sheet at a time based on which image you want to use. We will use the first method, separate images. Those images need to be the same size, and they will need to be drawn in such a way that the sprite doesn't appear to wobble as you replace one image with another. So the legs might move, for example, but the center of gravity should not. They will need to be aligned, and you'll need to blit them appropriately. The penguin from the text is a simple example because the penguin's body is always the same size and in the same location. It's just the wings, which are inside the body, that are changing. But it's still important that each penguin be aligned exactly the same within the image rectangle, off by just a pixel, and it will appear to wobble when you blit it. There are lots of sprite sheets on the internet that you can use either as is, or that you can use as examples for creating your own sprite sheets. Just remember to follow the licensing and copyright agreements if you use somebody else's work. In this video, we're going to animate this sign that says lights, and I have 3 images named light1.ping, light2.ping, and light3.ping. They are each 516 by 200 pixels, and the letters are located in exactly the same spot within the image. And this program is called animated neon sign.py. Let's run it first to see what the animation looks like. And you can see the sign. It looks like an animated neon sign. Okay, now first, let's look at the main program. We have a sprite group called group, and that contains the sign. We create a window and a dark gray background and blit the background to the window. The only event we process is a quit event. And then we clear, update, and draw the group that contains the sign. The interesting code is the sign itself. So first, here in the main program, we load the 3 images into a list. And if you name them as I did, light1.ping, light2.ping, light3.ping, then you can construct the image file names to load in a loop using string concatenation. Those are appended into the list called images. That is passed to the sign constructor. Sign is our animated neon sign sprite. Let's now take a look at that. It has three fields: the list of images, an integer called count, and an integer called image index. In the constructor, we call the superclass constructor and then set the image to the 0th image in the list of images. We set image index to 0, that is the index of the currently displayed image, and we set the images field to the list of images, and we get the rect. We then calculate an XY coordinate that will center the sign in the window and set the rect of the image to that coordinate. Finally, we set count to 0. Now what we want to do is periodically update the image to the next image in the list, and then once we've reached the end of the images, cycle back to the 0th image in the list. And that's how you animate a sprite. During the update, you switch to the next image in the list and set that as the current image. So that's why we have the image index field, so we can keep track of the current image and increase to the next image in the update method. Let's look at update. I don't want to switch the sign 30 times a second. We have only 3 images we're cycling through, and I want them to cycle a little bit slowly. So I'm going to increment the count variable at the beginning of the update method. Remember, update will be called 30 times a second. So I increment that, and then I'm going to change the sign image every time count reaches a multiple of 20, so every 2/3 of a second. I can check that using mod, or I could check for 20 and then reset count to 0 if count is 20. Here I'm using mod, so if count mod 20 is 0, then we've counted off another 20, and I increment the image index and change the image. Now once again, I'm using mod, but I could use an if statement to check if the image index has moved past the size of the list and reset it to 0. Instead, I'm using the image index mod the length of the list. You should review mod if you don't remember how it works. It's perfect for this sort of operation for cycling through a series of numbers. self._image index mod len self._images will take the value 0, 1, 2, 0, 1, 2, etc. repeatedly as self._image index is increased. 0 mod 3 is 0, 1 mod 3 is 1, 2 mod 3 is 2, 3 mod 3 is 0, 4 mod 3 is 1, 5 mod 3 is 2, 6 mod 3 is 0, etc. The mod is what's left over from the dividend after you've taken as many whole divisors out as you can. So what's left over from the 5 after you've taken as many whole 3's out as you can are 2, for example. So that's it. The update method changes the image every 20 times it's called by incrementing the index and then indexing in to the image list to get the new image, cycling around to the 0th element once it's reached the last image. I recommend you find a sprite sheet on the internet so you can focus on coding without worrying about creating assets, and practice creating an animated sprite from it. Keep your program very simple. Just focus on animating the sprite. Make sure you can do it without wobbling the sprite, and be as general as you can. Try not to hard-code any values in your final product. Once you can do that, you're ready to move on.